Hello everyone, and welcome to our latest webinar. My name is Yasen Stoykov, and I will be your moderator today. Joining me today here are Connor Vilenio and Atanas Kyriakov. Connor is from Enterprise Knowledge and will be the presenter today. Atanas Kyriakov is the CEO of Ontotext. Before we move on to the next part, I would like to quickly go over few organizational details that I think are important. First of all, this webinar is being recorded, and a link to the recording will be distributed over to you in a couple of days. You are, and all the attendees are currently on mute, and this is mainly to avoid background noises and also to enable the speaker to present without any interruptions. You can still communicate with us, however, using the question box in your GoToWebinar panel. We strongly encourage you to ask questions so we can have a meaningful Q&A session at the end of this webinar. With that, I would now give the word to Nasu, who will introduce our main presenter today. Nasu?
Thank you, Yasen. So we invited our partners from Enterprise Knowledge to deliver this webinar and share how taxonomies can be used for content recommendation. And to get a little bit deeper into this, the two main subjects are point one, how you turn taxonomies into knowledge graphs, and then point two, how and why a well-connected graph can put concepts in context and provide extra features to be used for better recommendation models for the main goal. And that's a very, very interesting subject to me because Ontotext has developed several recommender projects where we use big knowledge graphs of millions of entities, things like DBpedia, geonames, or paid sources, company lists, and so on. To make very good text analysis and then on this basis to do recommendation. One such recommender system is we deliver to Financial Times, so you get recommended reads at ft.com this way. But this scenario, it requires someone beforehand to build a big knowledge graph. And what Connor is going to present today is way more practical. Starting from a taxonomy that the enterprise already has, and then building a recommender system around it, and eventually, as needed, making it richer with external data or with more analysis. But you hear this story from Connor. Connor is one of the leading experts. Don't look at him while being a young man. He's one of the leading experts in enterprise knowledge. And he yesterday had a presentation at KM World that this is the biggest KM knowledge management event. And enterprise knowledge had 7 presentations, or 8. Am I right, Connor?
You're right, yes.
Quite a number of presentations there for KM World Connect, because this year it's virtual. So a couple of words about EK before I hand over to Connor. So Enterprise Knowledge is the largest dedicated knowledge management consulting firm in the world. So there are larger companies eventually, but if you take knowledge management consultants, EK is by far the most advanced and the biggest one. And that's why they're recognized for 60 years in a row as one of the top 100 companies in knowledge management to look for. Technically it is 100 companies that matter in knowledge management, and that's a big thing because you have all the big guys, and then out of a sudden, enterprise knowledge. By the way, we also have another couple of partners which work both with Ontotext and enterprise knowledge, part of this ecosystem that were to and had quite distinctive role at KMWorld, and they're both tool providers. Well, Enterprise Knowledge is consultant. Our partners Synaptica and Pool Party, Semantic Web Company, are tool providers. So with this, I want to hand over to Connor. I gave you sufficient background. I lost 3 minutes of the precious time for Connor. So Connor, the floor is yours.
Awesome, thanks so much. Yeah, thanks for the great intro. I'll just speak a little bit more about myself so you all can be introduced to me. So my name's Connor Vilenio. I'm a senior consultant, and I'm in the data and information management practice here at Enterprise Knowledge. That's me in pre-COVID days with some colleagues in our office here in Arlington, Virginia. So that's where I am. That's where I am talking to you today. So my background is in data science and data engineering, and I've been working with EK for a couple of years now, and it's really been my passion to bring the realm of data science in conversation with knowledge management, because knowledge management can be seen as kind of a more niche business area. And it, data science can really bring has a lot to offer to it, and we've been doing a lot of exciting projects with our clients and trying to do more advanced things and like what we're going to talk about today. So I have a lot of experience doing knowledge graph projects where we're building semantic models, ontologies, taxonomies, and then usually we're doing some kind of data integration work, building pipelines, and also helping to build products as well that can consume this data and ultimately have an impact on end users. So that's one of the cool things about EK is we are an end-to-end consultancy. We do both strategy and we can do strategy and also implement our technical solutions as well in partnership with our clients. So I've led a couple of different projects around knowledge graphs and building tools around knowledge graphs. So excited to share with you some of that experience today. So what are we going to cover today? Today, I wanted to share with you a little bit of background on recommender systems or recommender services. They're fairly well known these days, so just wanted to give a little bit of context to the presentation about how we view them at EK in relation with knowledge management principles. I also want to go over taxonomy and semantic models. If you're new to that kind of sphere or domain, I wanted to make sure that bases were covered, make sure everybody understood what we're talking about when we talk about a taxonomy and a knowledge graph. We'll talk about this kind of idea of turning a taxonomy into a graph and using that graph to power this recommendation engine. And we'll go over some considerations from our experience and how we've implemented this with clients in the past. And then, of course, have a QA section at the end. So recommender services. So obviously in knowledge management, we're very interested in different types of information retrieval features and making those available to our clients and their users. Very common to be talking about in this space, search, also things like faceting and filtering. And so today we're going to focus on recommendations, and recommendations, kind of what really define them is this idea of being able to proactively generate and retrieve information with minimal input from the user. This is really a nice feature because a lot of times when users are looking for information, they might not know exactly what they're looking for, exactly what they need. And so recommenders are good at really stepping into that gap and being like, hey, maybe you're interested in this, and really helping that user find information with limited inputs. It can be, it can be as simple as kind of helping correct a search query they have, or it can be as hands-off as just trying to use more indirect signals to try and guess what the user needs, and we'll talk a little bit about that in a second. So recommenders are awesome. They provide a lot of value, and some of the aspects around personalization, being able to actively engage with your users, by adjusting, content and information retrieval to what they particularly need. It tends to make things look smarter, more intelligent, and make services that really have a big impact. So one of the big things we know is that recommenders really promote content engagement and discovery, because again, it's helping you find things you might not even realize you wanted. So it helps users to really dig deeper into content repositories, find what's relevant to them, and go about their day from there. And these are everywhere, right? Well, I would be very surprised if many of the people on this call have not run into some kind of recommender that's really kind of even in their day-to-day. These are, of course, some big name ones from some major tech companies. And if you think about these, they're really useful features. They're really, if after you, especially in these times, after you binge many Netflix series, you might be thinking, what's the next thing I want to watch? And so Netflix, of course, uses information about your viewing history and information about the content to help you understand, help give some suggestions of what you might want to watch. Spotify has a really cool feature. For example, I use this at work very often, where I just pick one song and it generates a whole radio station, or it starts to guess, okay, hey, maybe you'd be interested in these other songs as you go along. And of course, Amazon, of course, would like you to add more items to your basket. So they'll make sure to add some related products to see if there's anything you might have missed when you were as you were shopping. But of course, those are the big ones that we know are user-facing examples of public examples of recommenders. We do a lot of work though with enterprise projects and recommenders, and these can be similar kind of things in terms of content recommenders that are more internally facing. So thinking about like adding features to a content management system or a intranet or other types of internal features that users are constantly looking to find information and to digest more information in their day-to-day. We use recommenders to enhance search features, because again, if you can do search well in terms of having that direct input from users, and then also cover the areas where the user maybe isn't giving great input to search or would would like other kind of results, it's a great way to improve those kind of features as well, and have new search result types and different things that are more helpful. And of course, also you can use this to enhance chatbots and other kind of push services. I kind of lump these two together, but for example, if you're talking with a chatbot, and again, the user may not, there's this issue, right, of understanding what the user wants, what they need, and being able to connect them with the right information. So recommenders are good to help you pull in better results there. And then, of course, when we think of proactive pushing of content, we worked with one client, for example, where their users really their internal users needed, as part of their day-to-day, needed to be up to date on the latest news and information in their specific domain. And so we set up a system that would notify them and select pieces of content, for example, and push it to them. So a lot of different variations of how recommenders can help. And these, of course, isn't even an extensive list, but these are some solid projects that we have worked on with our clients in the enterprise space. So what's interesting about today's conversation, right, is I'm going to present a kind of alternative way of doing recommendations that's really centered in knowledge management principles and this idea of semantics. So a lot of traditional approaches, they work well, and then this is not a matter of trying to say one is better than the other in that respect. This is more about trade-offs, right? And one of the big things that we see is that some of the traditional approaches can be very heavy lift to get off the ground. They might require a lot of user analytics, especially if you're using kind of collaborative filtering principles where you're trying to look at what the user cares about to make guesses about what the recommendation should be. Similarly, you have this idea of the cold start, right? That you're not sure exactly, you need examples to train your algorithms on to kind of develop an initial sense of what is relevant. And so it may be difficult to do that without a lot of good data. And another issue we've seen is black box, right? Like a lot of these are very technical statistical solutions that you'd be very difficult to know, well, why did you recommend this to me? And you still see that in, like even with Netflix, for example, it isn't really telling you why that it's recommending The Office, but you hope that it's relevant somehow. And then, of course, just again, because these are more technical solutions, very reliant on machine learning resources and SMEs, which can be another barrier. So today we want to talk about an advantage of doing the semantic approach, that we think is a little bit more accessible, especially when you're starting out and you want to show value quickly, which is always a big thing for us at EK, of trying to ensure success on our projects. So today we'll talk about the approach that does not require you to have a ton of user analytics. It's based more around your knowledge base instead, and specifically, of course, talking about taxonomies around the topical and other types of semantic models you may already exist that you're using to organize your content, and just building on those to start generating recommendations and determining relevancy there. And of course, we'll talk a little bit more in depth in a moment on that. And another cool thing about this is you get interpretable results because you're actually able to look back to what exactly in your semantic knowledge base is kind of triggering these results, and we'll talk a little bit about why that is in a moment. So this kind of alternative approach that is in the semantic realm here is one of the things you can call it is a knowledge-based recommender, because what we're trying to do is we are trying to bridge different pieces of content, and we're going to do that using an ontology, or using a single model or models that capture generalizable concept, facts, and context. And these are all the things that you care about in the business. And again, we'll go into details in a moment, but the nice part about this is that you focus most of your efforts on building up this business vocabulary, these business facts, and using that as the main focus, and then just applying the connecting points to that knowledge model to your content, and then using that now you have kind of a network or a bridge where you now are able to interlink your content and to start determining relevancy based on how content is related through this knowledge model in the middle. And so this is the semantic recommender, which we'll talk about today. And so again, it's content focused, which again lowers the barrier to entry because you're really focusing on the properties of content. And then it also, again, is semantic because we have this model in the middle that is capturing meaning, business context, and other types of things like that. And so we'll talk about what we mean by semantics here. So I know some may be more or less familiar with this space. It's a really exciting way of working with data and metadata. At EK, we like to share our knowledge organization continuum because we see different levels of complexity and different opportunities available at different types of metadata structures and organizations. And so looking at the left here, we have our folksonomy, and the idea of a folksonomy is literally just free text tags. Think of Twitter and hashtags, for example. These can be ways for users to apply topics to content, but again, there's not much control over it. It's very open-ended. A controlled list is where you now start to impose some control over what topics can be defined. And so you get more consistency, and it's easier to kind of link content and connect content to each other because now you have a set list, whereas before you may have more wild west of terms in the case of a folksonomy. Again, none of these are more or less bad in terms of just being approaches. They're useful uses of folksonomy and these other types of models, but again, this is more about what capabilities does each give you. And so we move in from a controlled list to a taxonomy. And this is where now you're looking at hierarchical relationships between these different values. And so very common to see this where with example powering faceted search, where you start from a more broad or general concept, and then you move lower in the taxonomy or more to a more detailed level farther down in the hierarchy to more specific things that are interesting to you. An ontology now is a different kind of knowledge model where you're able to, which is characterized by defining classes or types of things and properties on those classes, either properties that describe those classes of things or properties that connect to different classes. And so this is where we start to talk about building up a really deep semantic model, because this gives you the ability to find relationships, is where you get a lot of the ability to have increased expressiveness in your knowledge models. So as before, you really only could think about in terms of hierarchy, in terms of what is kind of a more broader term or narrower term. Now you can have more flexibility in generating more customizable and specific relationships. And then the knowledge graph is really where you're starting to use your ontology, which is this structured model, to instantiate data, which is to apply the ontology to your data, to your metadata, structure your data using the ontology, which allows you to end up with a really powerful semantic resource that is a combination of the metadata, the business context, the business facts, and in this one model that really has a lot of value for helping users understand what data is about, what it means, and how it may be useful to them. Of course, useful for recommenders as well. So just to drive this home because we're going to be focusing on taxonomies today. Again, this is a type of controlled list, a type of controlled vocabulary, but we're able to use it to describe or characterize explicit concepts of information, to capture, manage our data, and present it in a more organized way. And again, this is a very simple diagram here. Taxonomies can be more or less complex, but the idea is that we're really characterized by these hierarchical arrangements, typically of topical information, that helps us to organize and describe our data. And some more robust taxonomy designs, especially when we talk about thesaurus and that kind of thing, includes synonyms and other properties to help flesh out a little bit more and increase the usability of the model, especially if you're trying to capture the true conceptual idea of something, and being able to connect that with the labels or the different would show up in free text. And so the other big principle here is knowledge graphs. So we talked about knowledge graphs and how an ontology is used to structure a knowledge graph, and then you instantiate that ontology with data to end up with a semantic model that's just the knowledge graph. It's focused on capturing meaning. A really popular example that you might interact with every day if you use Google is their knowledge panel search result type that shows up on the right. You can see here an example with Michelangelo. And what's really cool about it is you're able to bring together a lot of interesting information for the user. And these properties and information are themselves also entities in this graph that you can further dive into. So it really promotes exploration of information. For example, if I started my journey with Michelangelo and I noticed that people also search for Leonardo da Vinci, I can easily click to Leonardo da Vinci and I'm looking at a different knowledge panel that shows the key context about him. And one of the conventions I want to introduce today, you can see here in the middle, is this idea of the 3 parts of a knowledge graph. And this goes back to the idea, the 3 parts of an ontology, right? How do you structure this graph model? You have classes, which are different types of things. You have relationships between the classes, and then you have attributes on those classes that describe them. And so when you define an ontology model, you'll come up with, you'll decide what types of things you care about, how they're related to each other, and what properties describe them. So you can see a simple example below where maybe we have an ontology about people. And so Jane is a person, and Jane is friends with John, and John has certain descriptors, as an example, height, weight, hair color, etc. So this is very, very simple. This would be like 1 or 2 or 3 facts in the knowledge graph. But you can imagine as you build this up, and thinking of the kind of knowledge panel example too, you start to get a very rich and detailed network of information that has a lot of nice meaning modeled into it. And so how are taxonomies, ontologies, and knowledge graphs related? Well, one of the ways that this can work is that you can use an ontology to actually model or capture your taxonomy. And what we mean by that is, again, ontologies are more flexible, right? Are very flexible in terms of being able to define custom relationships and to model different types of meaning. So one of the structures you can model in an ontology is a taxonomy. So you can, for example, SCOS, which is a very, very popular way to model taxonomies. It's actually itself an ontology. Uses the classes of concepts, which are connected by broader or narrower relationships, which is what is meant to correlate with a hierarchy. And then it also has other useful descriptors like alt labels, which are synonyms, for example, which can help you further flesh out your taxonomy. And so a lot of the leading tools for taxonomy management will actually, in the back end, utilize SCOS or utilize an RDF model to store the taxonomy data that the user is working with in the front. So you can see the knowledge graph where we've actually instantiated this taxonomy ontology, a SCOS ontology, with our taxonomy data in this dummy example. And you can see there that flavor is connected, which is a type of concept, is connected via these other concepts, which themselves can have properties.
Yeah,
so
Conor, you're doing great job here. Can I just have one question to you?
Sure.
Because people quite often get it. I mean, you're doing a great intro, and I agree with the way you're setting these concepts. But quite often people use ontology for too many things, and it's getting messy. So in this case, would you say that, would you agree that ontology represents some sort of semantic data schema that is used to represent the taxonomy?
Yes, I think that's a great way of putting it. You know, an ontology, another kind of way of describing an ontology is a graph schema. So this is a defined model that it then allows you to represent your taxonomy. And yeah, super useful and effective way to do it.
Yeah, just one more comment to us, and the way we think of this stuff at Ontotext is that ontology is more the logicians or the data scientist way of thinking about hierarchies. So you have way more rigid logical hierarchy, and it's about if you want set theory of inclusion of all the instances of one class in the instance set of the superclass, and so on and so forth. And that's not the way in which people think of topics and categories and the kind of concepts that you have in taxonomies most of the time. So in ontology, it's very important to have this proper inclusion and very rigid and logical and persistent semantically, formally class hierarchies. While in this example that you have flavor and then as a narrower concepts, bitter, spicy, and sweet, we see that in a taxonomy, people have no worries to have in an ontology, flavor could be a class, and then it can have instances like bitter, spicy, and sweet. While in a taxonomy, people don't make such a rigid distinctions between classes and instances, because the notion of the concepts that are you deal with there is more really the way people think about it, and people don't think of classes and instances most of the time. It's just more narrower and broader. And that's different kind of semantics. The way in which they combine in this case is that, yeah, you use SCOS as an ontology, which is as strict as an ontology should be to represent the concrete taxonomy, and that's wonderful. It just works great. So sorry that I hijacked a bit of your time, but yeah, to me there is we've seen many people who have hard time figuring out how these three terms combine. Thank you.
Yeah, wonderful. Thank you. Yeah, I think that's a great clarification because, yeah, these terms can be thrown around. There's actually a lot of different ways to describe the same thing. And yeah, I think that's a good way to summarize it and clarify it. I did want to mention one other vocab before we move on, which is RDF, and that's the Resource Description Framework. Now, RDF is actually a standard for actually how we physically can store graph data, and specifically, and the reason I want to bring this up, of course, because we all know and love GraphDB, which is a triple store and can store data in the RDF format. So you can see that if we think about classes and relationships and these connections, the way that this boils down and very simply with RDF is these 3-part statements. And so just something to keep in, we're not going to dive a bunch into RDF principles, but just something to keep in your back of your mind that the RDF is a physical way we can represent the data in a knowledge graph in an ontology. So let's talk about turning the taxonomy into a recommender engine. So the overall big picture here is that we're going to combine 2 elements. One is the recommender knowledge graph, and this is a knowledge graph that combines the taxonomy with your content. So we'll talk a little bit about how that works. And then the actual recommender service, of course, is a software program, and what it does is it derives and scores features from this recommender graph and uses that to determine relevancy between your pieces of content. So fairly straightforward in terms of the pieces of the puzzle here. And so the cool part about this is we get to develop this graph from our taxonomy, and that graph itself stores a lot of information about business facts, business meaning, and then that's going to translate very well to then doing some mathematical approaches and ultimately determining, from those business facts, what ultimately is relevant or not. So let's jump into defining our recommender use case. So of course, if thinking big picture of how EK typically engages with a client around a project for recommenders, right? We're working with key stakeholders and subject matter experts, and we always want to make sure to take some time to develop use case or prioritize use case. Really define what we're actually trying to achieve with our recommender, what the timeline is, of course, business priorities, et cetera, to make sure our project is going to be successful. And so this is a very important foundation for our project. And so I just wanted to bring it up because it can be easy to talk about these technical solutions and not think about some of the other decisions and processes you'd go through to develop your project to make it a success. So we work with our clients to really shape these. If they, we start from their initial ideas and we speak with different experts, different user groups, and help them define how this recommender could impact them the most effectively. We also, of course, work with them to analyze their IT infrastructure, their data sources, what's the state of their data, and can also assist with solution architecture in terms of how we're going to implement this recommender service in production. So, this is all the kind of behind the scenes or kind of key foundation that you'd want for a project like this. And so I just wanted to call it out as we go forward because I think it's, we see it as an essential piece of having a successful project like this. And so for today, I just wanted to have this kind of representative use case in the back of our minds, so it's a little bit easier for me to explain the concepts. This example is used to kind of bring together a couple of different clients I'm thinking about as I'm talking about this solution. So today we're going to talk about a recommender service that is going to suggest recipes based on the current recipe a user is viewing. So again, some of the high level we would have determined as part of our design steps is to, what is this purpose of the recommender? So we want to be able to, power accurate recipe recommendations. We want to know we want to really keep in mind who are the users or personas for this recommender service. In our case, it'll be a wide range of users, cooking novices and experts. So we want to make sure this recommender is more generalizable or flexible, I guess is one way to put it, to different types of users. We want to understand deeply the scope of what the content we're looking at. This will come into play, especially as we think about, what metadata do we need to worry about? Also, what taxonomies do we have in place? It's very common, and that's why we think this approach is very successful, is because many clients already have a taxonomy in place. And so, part of as we're starting off a project like this, we understand, what's the current state of the taxonomy? How can we use it for this use case? And also just understanding what kind of concepts do we or information are we going to run into in the content. And this is starting to get more into ontology development and understanding what are the key types of things and business ideas that we want to represent in our data in our semantic model. Like in the case of a recipe, it could be the ingredients, the equipment you use to do the cooking, the descriptions, instructions, different types of data concepts you could imagine could be relevant to our model. So now that we have that background in mind, basically the big step for building the recommender graph is to combine our content with our taxonomy. And there's a couple steps we need to worry about here. One is doing a content analysis to understand how our metadata actually is functioning in the content. Also, just understanding how what content metadata exists. You know, for example, you see the example below where we might have a recipe for spaghetti and meatballs. That we want to know, you know, who wrote that recipe card, what repository it exists in, what collection it exists in. Depending on the use case, depending on the client, we may or may not actually bring in the free text of that content. In the case of these recipes, it might be manageable to do that, especially if we want to apply, do some auto tagging and other types of NLP processes to apply our topics and taxonomy to that content, and that can be a helpful way to do that. And you can see here in our model below that you know, one of the approaches we found effective is to include kind of digestive versions of that content. And what I mean by that are maybe deconstructed, where we think about, okay, what are the different pieces of this content type? There's a description, the instructions, the ingredients, for example, and being able to kind of keep track of that in our semantic model, then we get more granularity about understanding where concepts are appearing. And that's where you're seeing in this middle step, right? Which is we need to be able to link our taxonomy concepts to our content. And so if we have topics in our taxonomy about food, like spaghetti, pasta dough, flour, you're seeing here, we want to be able to understand how those, and in our data have it modeled, how those connect to unique pieces of content. And this is where we're getting to building that knowledge graph, right? Being able to say, okay, spaghetti and meatballs is about spaghetti. The instructions are talking about pasta dough, and one of the ingredients is flour in this case. And it can be this kind of simple in terms of just literally what was mentioned. You know, what's the beauty of a taxonomy is you have a lot of power over deciding what is a concept, because again, you can control, you can store in that model the different ways that concept appears in your content, so you can handle synonyms and that kind of thing. And the last piece here, once you've been able to apply these concepts to your content, you know, using there's a number of ways you can do that. The last piece is actually growing your taxonomy and making it more semantically expressive. And this is where we start to introduce more custom relationships, where we start to say, okay, well, what are some business facts? What are some things that users care about that could be interesting to model? For example, spaghetti maybe has a prerequisite recipe. It could, you know, you might want to make everything from scratch, and so you want to look at your pasta dough recipe first before, so you can make some fresh spaghetti from scratch. You know, we want to be able to understand more deeply, well, how could pasta dough be related to flour? You know, it could have a raw ingredient, for example. You know, that, and again, this is meant to be generalizable, right? So spaghetti is a type of food, and foods can have relationships to other foods. You know, they can have prerequisite recipe relationships. Foods can have relationships to ingredients, and so it's these kind of facts that we're trying to build up about our in our knowledge graph, and trying to take the different concepts in our taxonomy and to make them a little bit more rich, to say, okay, well, sure, we've modeled these topics, and so we have that level of granularity, but now let's start wondering, okay, well, based on these different schemes, different types of concepts that I have in my taxonomy, how could they relate to each other, and what kind of meaningful statements can we make about these things? So you'll see in a moment how useful that is as we go into a more specific example.
Yeah, Connor, that's a great example. Yeah, by the way, that's a good example of how text analysis, in this case, analyzing this recipe, can help taxonomies and help enrich taxonomies, build taxonomies. And this way, there are plenty of ways in which text analysis can complement taxonomy management or taxonomy development, by finding concepts for relevant, finding candidates for relevant concepts or related concepts, synonyms, suggesting relationships, and that's the kind of stuff that you present. But we also have many projects in which controlled vocabularies and taxonomies help text analysis a lot. So it's yeah, and yeah, so there is a cycle. If you have the proper infrastructure and the proper strategy, you can get those help each other in cycles, and then you can get text analysis to help the taxonomy, then use the taxonomy to do analysis of documents, and so on and so forth. So yeah, sometimes we call it a tango. In our case, because we work with the slightly bigger concept of knowledge graphs, we can say that knowledge graphs and text analysis dance together. They're in a sort of tango because they very well support each other. So yeah, in this case, that's a wonderful example of how we can use text analysis to enrich a taxonomy and make it better interconnected, because that's very important for making a better recommender. Please go ahead. Sorry for the extended comment.
No worries. Yeah, that's a good point. So I wanted to quickly show you a demo in GraphDB. Now, it's kind of funny. There's many powerful features of GraphDB, but one of the most straightforward that we love to share with our clients is actually the workbench, the UI that comes built in with GraphDB. It has a lot of cool features under the Explore tab that helps you visually interact with your graph. And these can be great for sharing concepts with key stakeholders, validating your graph data with SMEs and stakeholders as well, and just overall helping users and even non-SMEs, people who maybe are just learning about this technology for the first time, to have a better sense intuitively about what an ontology is, what a knowledge graph is, and that kind of thing. So I have a set of data that reflecting our use case today. I'm going to ask GraphDB to show me the visual graph where surrounding the spaghetti and meatball recipe entity in our recommender graph. It's going to pull up this nice little model with entities and the relationships between them. So let's kind of explore this graph a little bit. And this is an example of the recommender graph. It's going to be an example of a couple of different pieces of content and how they're connected to each other now in our recommender model via the taxonomy. So of course we have some other relationships that maybe aren't as useful for recommendations. Maybe they could be. In our example, we're going to focus just though on taxonomy topics and that kind of thing. So let's take a look at that. So let's look at the description. We have an entity here that's capturing the description for this recipe card. And so if I expand that with clicking, I can see that it's tagged with a couple of different concepts from our taxonomy. So this is where we start to understand, what is this recipe card about? And this is where we start to be able to, via this intermediate knowledge model, connect it to other pieces of content. So of course we can expand spaghetti and see what kind of relationships we have there. Now you can see that we have it connected to another piece of text content that's part of a recipe card. And if I expand that, you'll see that it's our spaghetti and clams recipe, which is shared, which shares the spaghetti concept. Another thing you'll notice is that concepts can be related to each other, right? And this is where you get that much higher level of potential complexity and potential expressiveness, where you can, it's not just that things share properties, right? It's that you have properties that have relationships to each other. So spaghetti, for example, has this relationship to the concept of pasta dough, which again we talked about earlier, is because that we know there's something meaningful there about how pasta dough can be used to make spaghetti. We also know that since this is a concept, it is also connected to other pieces of content. And again, we can have links back to spaghetti and clam, because again, we know that we have this shared idea of spaghetti in the middle. But you can also end up with just a pasta dough recipe itself that you can see here. And so you can see in the red dots now, we have 3 pieces of content, and then we have our knowledge model in the middle, and how these concepts have been applied to the concepts as we go along. And the key insight here that I want you to take away from today is this idea of the knowledge network, or the knowledge, which is another word for the knowledge graph, right? This is a network of semantic meaning of facts that you can literally, if you want to share with stakeholders, you can dive in and actually follow the paths. You can look at, well, how is spaghetti and meatballs related to spaghetti and clams? Well, because they both talk about spaghetti. How is spaghetti and meatball related to fresh pasta dough? Well, it's because this is a fresh recipe, so you might say that they're both fresh recipes, but also you have this intermediate relationship between spaghetti and pasta dough, and that helps you make that connection. So the idea is that when we want to calculate relevancy, we examine the graph and we say, okay, what are all the semantic relationships that we have via our topic taxonomy, and how can that get us from one piece of content to another? And based on how we get there, that's where we come up with relevancy calculations, which we'll talk about here in the rest of the presentation. So let's talk about that. So the key intuition behind the recommender algorithm, or what you would put in your software or script that is going to evaluate the graph, really goes back to graph analytics, different ways of looking at the network and examining it and deriving features. You know, for those familiar with data science, this is the idea of feature engineering, right? You need to be able to derive useful data points from your maybe other data to help you make good decisions about what is relevant. So I've isolated here a single pathway in this knowledge network going from spaghetti and meatballs to fresh pasta dough. You can see that we have, you know, two steps through our taxonomy in the middle. And so we can start to generate some very basic and intuitive features off of this that, you know, in and of themselves will get you very far for generating a final relevancy score. And the idea too is that, of course, these two pieces of content are not necessarily just going to have one path between them. They'll have many paths. And so it's the kind of aggregation of these many paths and the graph analytics we can do on them that helps us to get to this, be able to calculate relevancy. So, you know, different features we can look at, you know, what type of concept is this? What scheme is it in? You know, this is a type of food. You know, how are these topics related to each other? You know, this is a prerequisite recipe. So we can assign certain weightings to different semantic meanings that we think are more or less relevant to users. So this may be a particularly strong one because we know, well, if somebody's considering cooking spaghetti, they really might want to just go all the way and make homemade pasta dough for that spaghetti, for example. But again, you have there's many ways to do this, but you know, fairly straightforward, just being able to observe what's in our recommender graph, because our recommender graph was designed to help us when we get to this step. You know, what are these features that really mean something and could be used to generate relevancy? And you see the bottom there as well, really straightforward one. How long is this path? How many intermediate steps did you have to go through the taxonomy to get from one to the other? And you know, the implicit meaning being that the more steps, the more complicated route you have to get from one to the other, the weaker maybe that relevancy is. But what's nice again is you can aggregate these together and get a full, deep picture of how content is related to each other as you're generating recommendations. And there, like I said, there's many ways to do this. You know, there's some certain things you might want to do in some kind of script so you have more hand control over how you're generating these features in a more like a traditional data science way. GraphDB though has some great plugins as well that may help you generate some additional data points or features that you could then plug in to your recommender algorithm to generate that final relevancy score. One is RDF Rank, which if you're familiar with PageRank in Google, this is the idea of looking at a node and a graph and understanding how many connections it has, how kind of central it is to the design of this graph. So you can imagine maybe something like salt, which appears in a ton of recipes. Everybody loves their salt and pepper, for example. Maybe you have a very high centrality, whereas something like clams, for spaghetti and clams, maybe be a little more rare kind of ingredient. But this is all kind of encapsulated in this RDF rank score, and we can use that to decide, okay, maybe if two things are connected via salt, that's a weaker recommendation, and we want to penalize the relevancy score there. Whereas clams, you know, is a little bit more meaningful. It's connected to less things, so those recommendations are going to be better tailored, better quality. The other kind of useful things that GraphDB has is its indexing features. There's a lot of different versions of the different variations of this, including things that help you with searching your graph. One of them, though, is the prediction-based index, where you can actually use the model of your graph to ask GraphDB to give you a relevancy score or similarity score based on kind of the aggregation of all the features in the graph. And so this is another approach of generating, you know, some kind of representation of similarity, which could be very useful to help you build that recommender right off the bat. And again, at EK, we use a bunch of, you imagine us doing an ensemble of things, right? We will take some information from a couple different places as we're doing feature engineering, some handmade, some from GraphDB, and then we can combine that into our final calculation. And of course, we also give the users the ability to configure and control kind of the weightings for things. And so you can more emphasize and de-emphasize pieces of your taxonomy even, or the relationships between them that you know would be more or less relevant to the recommendation. So just to wrap up, I did want to give a sample of one sample microservice architecture we've found success with in the past. Again, when we start to get into architectures of how you could implement a recommender system, there's going to be a lot of considerations you need to take into account of what type of approach you want to take. We found with many of our clients that these recommendations, because they're content-based, don't necessarily have to be real-time, so they can be done in batch processing events, at certain points in time. And one of the architectures we found success with, this uses an example from public cloud, which many of our clients are using. And this is where we put our recommender script into AWS Fargate, into containerized applications that we can then horizontally scale and that talk to GraphDB to pull relevant information and then to ultimately calculate the final recommendation scores, which are kind of stored in a type of caching layer. In object storage, you can also use other types of approaches there. And then of course you may have your serverless API that actually is looking up the data so that when your front end asks, okay, what's the recommendation for this page, it'll look up the pre-calculated recommendation. Again, one way to do this, we found great success. GraphDB is a champ in this kind of architecture. You can imagine with the horizontal scaling, right, that you're going to get a lot of concurrent requests to GraphDB. And we've had great success doing it this way, and GraphDB is excellent at serving up the data we need when we need it. So that's the kind of idea of the presentation. So again, this is a reminder, this is a semantic approach because we're focused on modeling meaning, capturing meaning. It's rooted in a taxonomy because we have that topic focus. But we've enriched and expanded that taxonomy into something greater, into this knowledge graph that connects our content to each other via our knowledge model in the middle. And then we basically write some software or utilize some built-in calculations from GraphDB that help us to generate relevancy scores based on those pathways or different properties in the graph. And that really can help us to generate some really useful, relevant recommendations that are explainable, because you can literally look up the recommendation and say, okay, what paths really are dominating the score here? And those paths contain topics. So you can say, okay, this was recommended because this topic was important and these paths dominated. So really cool in that sense that it's not a black box as well, because you put this effort into modeling meaning itself and business facts and context, and that ultimately allows you to have great success with these kind of projects and get running very quickly and show success early. So I appreciate everybody listening for the time. I wanted to save a couple minutes here to have some question and answer.
Thank you, Connor. I've been looking at the questions. I answered a couple of them, which were sort of more immediate. There is a question: are the scores generic, considering the semantics in the links? So I interpret this one like, if you have relationships with different semantics, would this be considered in how they affect the scores and how they contribute to the relevance scores, depending on the semantics of the relationship?
Yes, that's a great question. Because yes, if you're modeling a taxonomy, you're likely to have all the SCOS properties included in your graph. And so we've found success with our clients, keeping that, because again, especially if they have a taxonomy management system, that's what they're going to be seeing and managing in the front end. So they can continue to use their taxonomy management and government processes they currently have using those tools. And then we basically work with them to understand what do the SCOS concepts mean in terms of our relevancy calculations? So what does a broader relationship really mean? Those tend to be the most valuable, right, for recommendations, because typically if you're going, it's less risky to make a recommendation that goes through a more general topic, for example. So the point is there's actually many ways you can do this, but we tend to include SCOS in the final recommender graph, and we just work with our clients to align how they understand their hierarchy, and then mix that in with these new custom relationships, so we have a kind of complete picture of semantics that has been capturing different types of meaning.
Well, we got thank you, Connor. We got plenty of other questions. One is in regards to scoring. Have you looked at fuzzy logic mass assignment theory?
I'm not familiar with that particular approach. I don't know if there's any more context to that.
No, not really. I'm not familiar with this theory either, but we'll be happy to get suggestions. There is another question I have. Made from Protege. Is it difficult to import my project into GraphDB?
Is it difficult?
No, it's not difficult. You just import the AU files, so you can't import the Protege project in terms of the specific things, but the ontology model that you built there, you just get it in one of the many RDF syntaxes, be it RDF XML, Turtle, or something else, and then you can import any of those right away in GraphDB. Well, there are plenty of people that find your presentation, Connor, great. I'll skip them, not because it's not important, but let's go to the questions. So, do you think it is easier to go from taxonomies to a knowledge graph for enterprise in terms of user friendliness of the final application? For instance, the visualization of the network on GraphDB, than to start from a more complex ontology? So the question is, are taxonomies an easier starter than ontologies?
Yeah, that's a great question. It does, of course, I always have to say it does get back to how the project design and development goes at the beginning. Really what we're looking for in these kind of projects is what is the alignment between a taxonomy, the taxonomies that the enterprise has, and any potential ontology projects that are going on. We do find the reason we think taxonomies are useful is because we do find that because taxonomies typically have use cases already around organizing and adding meaning to content, that typically when we want to make content recommenders, it's a great place to start. That being said, like you saw here, we do a hybrid model, right? It's not just your taxonomy. We do expand it with other ontological properties and structures. And so you could imagine a case, right, where you either do that from scratch and you develop a new ontology based off of that, or maybe there is an ontology either open source and publicly available that could be useful, or across the enterprise that has already been developed. Again, the biggest thing though is what's the alignment with your use case? What do you mean when you say a piece of content is relevant to another, and you use that design kind of North Star to decide what's the best starting point?
Okay, one more question. Obviously, some people are interested to see what is the skill set, what skills are useful for enhancing or even creating new taxonomies. Is this work done more easily by content skilled person or a data skilled person?
That's a great question. We at Enterprise Knowledge, of course, being dedicated knowledge management consultants, we have a dedicated staff of ontologists and taxonomists, so actual individuals who are skilled in doing that kind of data modeling and working in the semantic space. We understand that not every company may have that. Some companies have knowledge management wings or these skill sets that may be already acquired. Others may not. So for those who maybe don't have a strong background in this yet, of course we are always there to support. But it really takes the kind of an individual who can bring together the two types that were mentioned, the content SMEs and the data SMEs, right? Because then that's where really we sit too, is you need to understand what the content about, you need to understand the value of it, you need to understand how it's described, what it means, that's essential to the design of any recommendation system. But of course, you also need to be firmly rooted in the data. What systems and sources do we have? How are they connected? How can we access that data? What are the current schemas and models already in place, and how can we combine that with a new model, or dovetail that, or intermix that with something that we're developing? So probably the short answer is we recommend somebody that diving in, kind of, there's this new term, a knowledge engineer, where you're somebody who really is into the semantic space, and we've seen taxonomists, data scientists, ontologists, and data and content people alike kind of grow these skills, grow into this space. So it's a really definitely exciting time for the domain.
Yeah. Okay. So with this, we got most of the questions answered. Sorry, just to look at the one that popped up. Connor, at my company, we are looking into creating an ontology to formalize our knowledge. We are used to experts creating PowerPoint, PDFs, and other visual materials. What is your recommendation when it comes to alter the way of working around the knowledge management and documentation? And what are the dangers with yeah, okay, then it gets truncated, so you may want to answer to this question. So it seems that it's about people who are doing great job in creating some diagrams and stuff in PowerPoint and PDF.
Mm-hmm.
But then when you have to make this knowledge more formal, there seem to be people who have troubles in getting into more formal discipline of building proper taxonomy or something else. So what would be your recommendation of how to work around this? So how to make it easier for experts to start doing a formal taxonomy, for instance?
Yeah, no, that's a great question. Probably I'd answer it in two ways. One is to try and look at, there are so many excellent ontologies that are publicly available, fairly intuitive, right? To start taking a look at those and see how are they documented, how are they constructed. You'll probably find an ontology for almost any domain, and some that use different kind of stylistic approaches to how they actually decide what's a good relationship, good classes, all those design decisions. And so you can look at those and see, okay, based on what I need for my project, what makes sense to my users, what I'm trying to model, maybe there's an ontology that might not exactly be my domain, but I really like how they've named, kind of come up with, made their design choices for that ontology. And so you can glean a lot of good information from looking at these ontologies. The other I'd just say is, I have a fairly technical background, and there's a lot of value that comes from the development sphere, right? Using versioning software, for example, like GitHub, which helps you to collaborate on code and better design code. And so when you're thinking of ontology, right, it is a data schema. It's a little bit less like code, right? But there's a lot of really important things that are used within development, software development, to help do exactly the same thing. How do I make the right design choices? How do I refactor my code properly? And so if you have a developer wing or department at your business, looking at some of their processes they use to come up with data schemas for their software and that kind of thing. If you have any experts that have any information on that, people, even database administrators, what are some of the ways they formalize their models? And you can learn a lot from those as well. So that'd be probably the two different ways if you were going to start from scratch, other than, of course, dropping us a line at EK, and we can help you as well figure it out.
Okay, I'll give chance to the last question because we are already a little bit over the hour. Do you use upper level ontologies, for instance, to integrate domain ontologies?
That's a good question. in our particular case, I would say no. We haven't, I guess put it this way, we typically don't find a use case where that's necessary. It does become necessary though, as things grow, particularly when we're talking enterprise and we're talking a use case, when you start to get out of more than maybe a few use cases or a few different kind of ontologies that might be useful to different departments. So as you grow, this is a consideration for scale, right? As you grow your ontology, as you are trying to capture more things across your business, it may be useful at that time to consider using a kind of a meta ontology or a model that helps you to structure and interlink these separate, disparate models that you have across your business. It's not necessary in every case, you know, because there are some different things you'd want to worry about, but you do see that happening with some of the very large ontologies that are implemented out there, like Wikipedia's, for example. They're using approaches like that.
Yeah, I'll have a short comment here because yeah, I've been working with upper level ontologies. I'm probably getting old for 25 years. And all the way from Psych to many other, yeah, Sumo, Dolce, whatever upper level ontologies. These resources, I mean, they're mostly useful if you really, probably if you're building the knowledge of a 7-year-old kid like Psych is doing, or something as broad as that, to give very broad understanding of everything. So there are relatively few projects where you need an upper level ontology of this type. But then if you think of very generic domain specific ontology like FIBO, the financial industry business ontology, you can think of it like an upper level ontology that you use to consolidate several more specific ones that you need for a bank or for insurance company or for a group that has several financial services businesses. So in this case, FIBO, although it has like, I don't know, 1,500 concepts or something like that, so it sounds big. It's not gonna cover many specific concepts that one may need in a bank, because even with this 1,500 concepts, it doesn't cover everything, even in one type of financial services business. So in this case, you can use FIBO as a higher level ontology to integrate several more specific ontologies that you need for investment banking or for insurance or yeah, God knows what. So yeah, using big ontologies to integrate small ones is a valid approach, and we've been using it in several projects. Using the upper level ontologies, which is like at the philosophical level, I enjoyed doing it, but we've seen it adding value in very, very few projects. So yeah. The big message is try to look at ontologies that are out there. Many of them are either application specific, either domain specific, and try to reuse parts of them. You don't necessarily need to subscribe to incorporate them and to use them entirely, but they can help you bootstrap yours. And that's all the way from FIBO that I mentioned. Then you have the provenance ontology, for instance, that is very good for capturing different aspects of provenance, that specific aspect of an application. There is plenty of stuff, and that's the beauty of using ontologies, because you have all these pieces out there that are ready. You can just get them and use some of this stuff in your application without having to invent it all. But yeah, I'm getting too verbose again. We are 8 minutes past the hour. Kona, this was one of the best webinars that we got on this channel. Thank you very much.
Awesome, thank you for having me.
Yeah, we'll review the questions. We got reference to this fuzzy logic theory, so we can extend our a bag of tricks next time.
Sounds great.
Yasin will take care to follow up to our attendees. Thank you for watching us.
Thank you, and have a nice day or evening, depending on where you are. Thank you from me as well. Bye-bye.
Take care.
Thank you. Bye-bye.